I wanted to go over another example of solving an equation and related inequalities graphically. I'm sure you're familiar with the setup of these equations so far and inequalities so far. But I did want to hone in on the fact that now we're dealing with radicals. So with example 8, again, if we are solving graphically, for all of these, we're using our TI, and I really prefer the root zero method for solving all of these. And when this happens, I prefer when I start off, so I can get an overall sense of what I'm looking for, is I'm going to make sure that all of these, this equation and both of these inequalities are rewritten so that 0 is on one side and the rest of the terms are on the other side. So I can do this nicely by subtracting the square root of x plus 18 from each side. So what I end up seeing for part A, I see 3 plus the square root of x minus 11 minus the square root of x plus 18 equals 0. For part B, same idea. I see 3 plus square root of x minus 11 minus square root of x plus 18 is now, just be careful, it's greater than or equal to 0. And then part C, I'll write a little off to the side. I have the same idea. 3 plus square root of x minus 11 minus the square root of x plus 18. Just paying attention to the inequality symbol. This case, it's less than or equal to 0. So the number one thing we always do first is we need to solve this related equation so we can get a picture of the graph. So I will do so. Let's go back to our TI. And I think I have an old picture there. So let's go to our function editor. We'll clear this out. Now I just have a problem reminding myself what did I write. So now I have my y1. I have 3 plus square root of x minus 11. And then I have equals, no, I moved the x plus 18 over. So I'm gonna say minus square root of x plus 18. So I'm using the root zero method. So I enter and I graph it. And I have a feeling based off of the numbers, I'm not seeing anything graph. So this usually has to do with, first double check, is your function highlighted? Because sometimes it accidentally gets deselected, and we see that the equal sign has it's bold. There's a black box around the equal sign, so we're good to go there. So then the next idea would see, maybe we need to widen out our x min or x max, or our y min or y max. I'm going to start looking at the x-axis. Since I use the root zero method, I know that my solution, if it exists, it has to be along the x-axis. The fact that I see numbers that look like 11 or 18, I may want to widen it out further than the -10, +10 range that I usually see. So I'm going to go to my window, and instead of -10, maybe I'll just take it to like negative 30 or so. And again, it's always random. I can only shrink it down if I think it gets too big. So I have -30, +30, and I see what happens with my graph. And now I'm starting to see, okay. So it looks like there's really nothing happening on the left side. So maybe the right side I want to interpret a little bit more. So I could play with my window a little bit more. Maybe I don't need to see. Maybe I'll keep the x min back at -10 and maybe make the x max 50 or so. Just so I can get a clear idea. And now it's a little prettier. Now you'll notice you don't really need to see that much of the y-axis. You can shrink down the y-axis so you see a little bit of maybe a steeper radical curve for yourself, but this is sufficient for us to solve what we need to solve. So I'll just go with it. So what I'll do is I'll copy it over for myself. For solving the equation, I'm looking for the x-intercept. So I see that it's crossing the x-axis somewhere along this range. So I'm going to say second trace, and you've done this numerous times before, so you're probably feeling pretty good right now. Okay, we're going to choose the 0. And we have to go a little to the left to choose the left bound, and go a little to the right. Now, if your curve is super shallow like mine is, I have to exaggerate it so I can see for sure. Have my right bound, and I know my intercept, x-intercept is in between those two arrows. I press enter, and I got something that's a repeating decimal, and that happens. And you probably, maybe if you solve this one analytically, you can then go back and compare and see if this is consistent with your answer. So it's about 22.11, we'll say. And so I can attempt, see if this copies over, but I'll just draw a quick sketch on it because that's what you usually do anyways. So let's go back to our function, our drawings. And I'll draw my graph of how I thought it was supposed to be. So it looks like it's a radical function doing something like so. And maybe I could be a little more accurate, you know? If I have my calculator screen in front of me, I'd probably have a better time with that. So let's do that. So maybe I have, it looks like it's a little bit wider. So we'll do something like this. So I know it looks kind of shallow. It does follow a radical properties. It is a little curvy. So kind of keep that in mind. But we did figure out what this boundary point is. It is about 22.11. And therefore, that's the solution to part A. So it's just a single number. And the calculator only really allows us to approximate. You may have other techniques. If you notice that you had a repeating decimal, there are ways to figure out the exact fraction that goes with that. I encourage you to look that up on your own, and it could be fun, but not necessary for this class. So part A, we're good to go. Now with part B, we're now interpreting for ourselves greater than or equal to 0. So again, if you reword this into English for yourselves, I'm looking at what values of x give us y values that are positive. In other words, we want to say, where do we see the function above the x-axis? And if you're looking, is it to the left of 22.11 or is it to the right of 22.11? By now, you're probably saying, oh yeah, it's to the right. So I just need to describe that region. So the solution for part B, we would say, it starts at 22.11 and it goes all the way out to infinity because it looks like the function is never ending at that point. Now, the other thing we want to double check on our boundary point, should we have parentheses or brackets? We will use brackets due to the inequality symbol. So now we just use the same graph to interpret the solution to part C. And just to help you out a little bit more, I always like to rephrase it just in case. Less than or equal to 0. We're asking ourselves, what values of x give us y values that are negative? And that's, again, interpreting that we are below the x-axis. So you're trying to say, well, it can't be the yellow region because those are values of x that give me the function above the x-axis. It's got to be something to the left of 22.11. Now, be careful. It is true that it's to the left of 22.11, but you can't go all the way to the left. You can't include all values of x because the function has a stopping point. So I kind of have the x-axis highlighted for just a portion of it. My job now is to figure out what is that x value for that stopping point. So I can start off with my solution, just kind of giving myself a hint. It's going to be an unknown number because I'm describing the turquoise region. So I have like a question mark. And it's going all the way to 22.11. So at least I kind of know this. And I have a bracket. Probably will have a bracket because you do have a function that's below the x-axis at that point. So I just got to figure out what that value is. Now you can go back and you could kind of play with your TI to see if you do have a value. But sometimes you notice that it doesn't give you like a clear idea. You can play with trace and you might have a good idea of what it looks like. So another way to explore, and you can kind of see where do you start ending. So you kind of see like, okay, 10.9, then at 11, but like it doesn't give you a precise value. We could probably guess that it's the x values are starting around 11 or so, and it's probably true, but we really need to verify it because it could be starting at 11.1, it could be starting at 10.9, we are not sure. So remember, what we have to do to find that endpoint is we have to utilize the domain of our function. So I'm going to go back and address this with you. And if I'm going to look for the domain, I have a little space over here. I need to understand that I have two radicals in my situation. So I have a radical x minus 11 and a radical x plus 18. So we have to account for both these at the same time. So what you're doing in both cases is you're setting the radicand greater than or equal to 0. So if I'm looking at this, I know x minus 11 must be greater than or equal to 0. And at the same time, square root of x plus 18, the x plus 18 part has to be greater than or equal to 0. Now, if you solve this, you'll notice it's a compound inequality. So nice linear, at least. X is greater than or equal to 11. And at the same time, x is greater than or equal to negative 18. Now you basically just take the inequality that covers both of these. So if you have a hard time seeing it, your TI could give you a big clue. Remember how we were talking about it looks like it's hovering around 11? And you're probably right when you're thinking, oh yeah, it has to be greater than or equal to 11. That is true. But let me just kind of show you just in case. If you were to plot these on the same axis, x is greater than or equal to 11 versus negative 18. So we have negative 18 here, 11 here. If you want to be greater than or equal to 11, you'd be going this way, and the shading would go this way. If you want to be greater than or equal to 18, maybe opening up to the right, and the shading would go this way. Well, what covers both regions is the inequality x is greater than or equal to 11. So right away, we kind of say, okay, we've got that boundary point now. That boundary point has to be 11. So now we know that we have an 11. So now we can modify this. Let's say go back to the solution. That question mark right there is actually equal to 11. So now we have our solution for when the graph is less than or equal to 0. It's in the turquoise region. It goes from 11 to 22.1. Both boundary points are included. So take a little time, practice this a little bit more. By the time you're done with this chapter, you're probably really going to see how much you've grown from the first day of class to now that you can interpret graphs. So I hope you feel proud of yourself. I'll see you in the next example.